Hello everyone and welcome to the fourth video in this series. So today we'll be discussing partition equal subset sum, and my strategy usually while selecting questions for the video is that if the question has something new to offer, if we can learn something different in a question, or the question has to be harder than the previous question. So I felt that there might be some new things that we will be able to discuss in this question. So yeah, I thought let's go ahead with it. So without any further ado, let's move to the question. So the question actually is really simple. So we are given an array of positive integers, and we need to find if it is possible to divide the array into two subsets such that the sum of elements in both subsets is equal. And it is given that there will be only positive integers in this array. Now there is no constraints on what elements can go in which subset, so every element has a free choice whether it wants to be a part of subset 1 or whether it wants to be a part of subset 2. So one naive approach that might come to your mind is that can't we do this question with a greedy approach? And based on the greedy approach, what we do is that we keep two sums representing our two subsets, and at every step we try to balance the subset. That is, if my sum for subset 1 is smaller, I will add the current element to subset 1, and if it is larger, then I will add the element to subset 2. And if at every step I'm trying to balance the two sums, then towards the end the two sums should be equal. I mean, if it is possible to make them equal, then they should be equal, otherwise it is not possible at all. So this strategy might not always work, because if we are trying to balance the sum at every point and we are not paying attention on what elements are left in the array, we might not be able to reach a global optimum. We might be stuck in a local optimum. So I'll give an example for this. So obviously for this approach to work, we have to first sort the array. So let me assume that I've already sorted the array and the elements are something like this: 1 2 3, and then there's an element, say 6. Now if we are trying to balance the two subsets at every point, initially both the sum will be 0. So I will add the first element to first subset and the sum will become 1 and 0. Now at second time I will try to balance the sum, and it seems like it would be a good idea to add this to subset 2. So this would be the state. Now since subset 1 has smaller sum, I might want to add 3 to subset 1, so the answer will be 4 and 2. And here I will add 6 to the second subset, so the two sum will be 4 and 6, and we were not able to make them equal. But we know that if we would have put 1 comma 2 comma 3 everything in just one subset, then we would have been able to get two subsets with equal sum. So as it is visible clearly, this greedy approach will not work. There's another approach, greedy approach, where we think we might want to put the pointers at the two end, and then using a two pointer approach we'll try to balance the two sums. This approach will fail for cases, and I'll not explain here why it would fail. Maybe you can spend some time in seeing that what could be a possible two pointer approach and what are the cases this two pointer approach is going to fail. Now we have discussed the greedy approach. What the second approach which might come to our mind is that why don't we try to make all the possible cases for whatever subsets are possible. If there's a possible case where the two subsets have equal sum, then our answer will be true. Otherwise, if there's no possible case from all the in our total search space where the two subsets can be of equal sum, then the answer would be false. And recursion is one of the algorithms that helps us to check all the possible cases which we can come up with. So if there's any time where we want to generate all the possible cases and want to create the entire search space, then recursion comes in very handy, because what we are doing in recursion is nothing but at every point we are making recursive calls based on what are the possibilities. And when we are making recursive calls for all the possibilities, ultimately what we are doing is that we are generating every possible case. So if we see, if I have an array something like 1 comma 2 comma 3, So all my elements in this array have two choices. Either they can be a part of subset 1 or they can be a part of subset 2. If I make two recursive calls at every point for every element, ultimately what I will have is all the possible cases. And in these, as we discussed, in all these possible cases, if there's a case where the two subsets will have equal sum, the answer for our entire problem, or the answer for the entire input, will be true. So if we try to draw a recursion tree for this problem, then it will be something like that. I'm assuming that the first element is the sum for first subset, the second element is the sum for the second subset. So the first choice would be that one will be a part of subset 1, nothing in subset 2, and the remaining array will be 2, 3. And here nothing will be in subset 1, one will be a part of subset 2, and then we will have remaining array as 2, 3. Again, 2 will have the option to be a part of subset 1 and the remaining array will be 3, or 2 will be a part of subset 2 and the remaining array will be 3. Now similarly for this case, now I'm not expanding the entire tree. If we see here that one of the options where 3 chooses to be a part of subset 1 and the array will be empty, obviously we have used all the elements, we see that in all the possibilities that we were generating, we have got one possibility where we were able to make two subsets with equal sum. So the answer for this entire input should be true. Now this is one intuition that we have not discussed, where we kind of use recursion to generate all the possible cases, and thinking this way also comes in really handy. So I have just added this intuition here, and because we have been following the intuition of saying that we assume that our method works for a smaller input, and we just need to think about that what we want to do at our current stage. If we take care of that, we'll get our final answer. So using that intuition as well, we can see that recursion will work for this question. So when we are at 1, what we do is that we blindly delegate the task to 2, 3. So we have taken 1, we'll take an action for 1, and we have blindly delegated the task for 2, 3. And for 2, 3, we'll check that if it is possible to make two subsets with equal sum. Now for 1, the step we need to take is either add 1 to sum of subset 1, or either add 1 to sum of subset 2. So we have delegated our task to a smaller input 2, 3, and we have taken the action to add 1 to subset 1 and subset 2. And this way, if we approach recursively, we'll be able to find out the final answer. Now let's discuss the time complexity of this solution. And the time complexity for this solution is also pretty interesting. If you see that this question actually does not suffer from the problem of repeating subproblems. So we do not have that issue. We are not calculating a subproblem again and again. But still, the time complexity for this approach is really bad. Why is that? Because let's try to calculate what are the total number of possibilities. Now, every element in our array has two options, whether it will be part of subset 1 or whether it will be part of subset 2. Now what would be the total possibilities or total case possible? It will be 2 into 2 into 2 for all the elements. So 2 into 2 into 2 n times. So the total number of possibilities will be 2 raised to power n, where n is the number of elements in the array. So if you see, if we are generating all the possible cases, then the computations would actually be more than the total number of cases, right? Because we are doing some intermediate steps. They are just leaves. The leaves in this tree are going to be 2 raised to power n. So the total computations are going to be even greater than 2 raised to power n. So if we see that the time complexity for this solution is going to be really bad, just because we are generating all possibilities and the total number of possibilities are really high. So if you see, our constraint is that the length of our array can go from 1 to 200. Now what in case when length of our array is 200, what would be the total number of computations? It will be more than 2 raised to power 200, and we know that it is impossible to calculate this. It is impossible to calculate 2 raised to power 200 total combinations. So given the constraints, given the nature of the problem, obviously recursive solution is not the best suited approach for this problem, but yet it is one of the approaches, and we have discussed this approach because because it is a series on recursion and we wanted to understand the concept of recursion. Plus it also gave us an idea of another intuition, where we see that whenever we want to generate all the possibilities, we try to use recursion. So when we'll code the solution and when we'll try to submit it on Leetcode, if the cases are good enough and they have covered all the possible scenarios, then our solution should not be accepted. It should run into time TLE for the cases when the size of the array is very big. So let's try to code our recursive solution and try to submit it. And I'm hoping that our solution would not be accepted and it will run into TLE for some of the cases. So here, as we discussed earlier, we would need a helper function. Why would we need a helper function? Because at every step, we are taking a decision for a particular index. So we need to know that at this step, which index are we considering. So there will be an extra helper parameter. So that's why. Check all possibilities. Obviously one input will be our original nums array and the other will be the index, and we would also need two helper parameters to hold the current sum of the two subsets. Right. So as we know that what are the two possible cases that we are going to have. So the two possible cases that we are going to have is either we'll add the current element to subset 1. So S1 new will be S1 plus nums of index, or we will add it to S2. Now once we have created two new sums for the two new possibilities, we will delegate our task to the remaining possible elements. So we'll call check all possibilities and we will pass nums, and in the first case we will pass s new and s1 new, and we will pass s2, and obviously we'll pass index plus 1 because we are delegating our task delegating the task to the remaining array. What would be the second case? Obviously the second case is that when the element is included in s2, so we will pass s2 new and s1 will be passed as it is, and we'll delegate our task to the next element. Now we know that our intuition says that we have to assume that this method will work for a smaller input. So this method is going to give me the correct answer for my subproblem. Now if this is going to give me the answer for subproblem, I know that my answer for this stage will be true if any of these possibilities return true. So what would be the answer for this stage? I've just checked the answer for my subproblem and I have taken the OR for both the problems, and my current answer will be OR between two answers that are returned by my subproblems, and I'll return this answer from my current step. Now I need to come up with a base case. So base case is pretty simple. Base case is when we have checked all the elements, when we have included all the elements either in S1 or S2. So in that case, our index would become equal to nums.size. Basically it has our index has gone out of bounds. So in this case, we just need to check if we have reached in a base case, and if we were able to make S1 equal to S2, we will return true. If we were not able to make them equal, then obviously we will return false for this case. So we have given our base case. Let's just call this method. So initially we will pass 0 for both the sums. Index also will start from 0, and we have passed our nums array. So let's try to submit the solution. First let's try to run the solution. So it worked. Now let's try to submit it. So as we can see that this was a pretty big input. I'm assuming the size of the input is much greater than the computations that we could have achieved, and that's why we have got a time limit exceeded. So we know that the approach we used was correct, but given the constraints of the question, we would have to come up with a different approach that we'll discuss in another series. But I guess for now, I'm hoping that you have understood how recursion is relating to this question and what concepts of recursion are being applied here. So I guess that's it for this video, guys. If you have any doubts related to this video, just mention in the comment section and I'll try to address as many doubts as I can. Thank you everyone. Take care and keep learning.